Okay, so we've talked about circles both at the origin and centered otherwise. That's going to lead us into ellipses. So, an ellipse, we first have to get what the definition is. And so, the definition for an ellipse is a set of all points in a plane such that the sum of the distances between P and two fixed points, which are going to be called the foci, or each one's a focus, is constant. So in a circle, what happened was all the points were equidistant from one point, from a given point. But here, what's going to happen is all the points are equidistant to 2 points, and it's the sum of those differences. That's kind of hard to get a handle on. So when we construct it, I'll put this link just on the regular Google Classroom too, but we can see what happens here. I'm going to drop this down a little bit. Maybe I'll even get rid of it here. So if I have this, get rid of this. So we start off with our coordinate plane. We're going to make, here's our center. We are going to be centered at the origin. We're going to make 2 points equidistant from that center. So these 2 points are going to be our two foci, F1 and F2. And then the next thing we're going to do is we're going to come up with some distance. And so if you were doing this, you'd have a string and you'd have 2 pencils. You'd stretch it out. And then you'd line up those 2 pencil points to the foci. And then you keep that string taut, and it makes the ellipse. Ellipse is a lot like an oval. The definitions are a little bit different, but that's how we can certainly picture it. So if you see that running through just full speed, we're going to make 2 points equidistant from the center. This is our center right here, always at the origin right now. That's all we'll get to this year. And then we're going to take a string or something that's equidistant. So that string never changes. This never changes. It's the same when I add those two things together, whether it's here or whether it's here, those two distances add up to the same amount. All right, so let's move on and let's start coming up with the important parts of an ellipse. So an ellipse can be rotated this way. I would call this the horizontal ellipse, whereas we can also have one that's taller or skinnier up and down. This is what I would refer to as a vertical ellipse. And so you just want to sketch those in your notes so you'll be able to put some diagrams in there. So this is going to be the center. And I know I've said it a few times. Let me make this a little skinnier. The center for everything we're going to do is going to be 0, 0. Other important parts are these 2 points. Each one of those is a focus. So when I think about where this is oriented, I go left and I don't go up and down. So left is a negative value. They use C for the focus, so it's negative C0. This then, it's the same distance, so this would be positive C0. The other important parts of the ellipse are the 2 points along this line that the center and the foci are on, where it intersects the ellipse, these 2 points. Each one of those is called a vertex. And the vertex, again, it's on the horizontal in this. I go over so many. This time I'm going to the right first, so it's positive. They use A, so it would be A0. Over here, the vertex, same distance, so it would be negative A0. Then the other 2 points that are important are where it intersects this way. This is called the co-vertex. And I've gone up, but I didn't go left and right, so 0B. I've gone down, so this co-vertex is 0, negative B. The vertices, co-vertices, center, and foci, those are all the things we're going to be naming. Just a couple other things. This longer axis is called the major axis, and that's the longer one. And this one is the minor axis, which is the shorter one. And so obviously when we talk about circles, we also talked about equation. That's going to be important for the ellipse as well. So down here in this corner, I'm going to put the important information. So the equation, very similar to a circle, it has an x squared addition and a y squared, and it's going to be equal to 1. There's no radius here. The other difference is the x squared is over a squared, and the y squared is over b squared. So there's my equation, x squared over a squared plus y squared over b squared, and it has to be equal to 1. It has to be equal to 1 to be in standard form. So the things that we are going to record, or we're going to write down, well, that's not how you spell record, is we're going to write down the vertices, and you can just put V, you'll see me do that. And so the shorthand, vertices are this way, shorthand way to do that would be plus or minus A0. The co-vertices, and you can put CV, that's going to be, co-vertices, these 2 points, 0 plus or minus B. And then the foci, and that's going to be these 2 points, so plus or minus C. Now, we see the A and the B in the equation, but where does this C come from? Well, we get that from this equation. C squared is equal to A squared minus B squared. Tied to that Pythagorean theorem, Pythagorean theorem is addition. Don't worry, we're not going to go into exactly how those are related. All right, so let's see how that differs a little when we look at the vertical one. The vertical one, this is still our center. These 2 points are each of focus. And so that's going to happen, remember focus is C. That's going to happen at 0, C. And this focus is going to happen at 0, negative C. This is the longer axis. So again, you don't need to know this part, but this is the major axis. And that makes these 2 points each a vertex. The vertex is still tied to the A. So this would happen at 0A, where this one would happen at 0, negative A. That makes this one our smaller axis, which is that minor axis. So that's how we tell the difference. The vertical one, the major axis, is a vertical line. These 2 points are each a co-vertex. And so that's happening, remember co-vertex is B, so that happens at B0. And this co-vertex happens at, negative B0. Let's see how the equation differs. So the equation differs a little bit. It's x squared over b squared plus y squared over a squared still equal to 1. So the difference is where the a and the b is. But we got to remember those are going to be plugged in with numbers. But remember the A is tied to the longer axis, the major axis. That means A has to be the bigger number. So A is always going to be the bigger number. I'm probably going to go back and add this over here. A is bigger. So whatever variable the bigger number is under, that tells you whether it's going to be vertical or horizontal. So then we are also going to record our vertices, our co-vertices, and our foci. I'll start using the abbreviation. So shorthand way, the vertices are 0 plus or minus A. Co-vertices plus or minus B0, they're along the horizontal. And the foci should always be in similar to the vertices, 0 plus or minus C. And the way to get that C is still the same way. C squared is equal to A squared minus B squared. And that's always going to be a positive number because A is always going to be bigger, meaning A squared is always going to be bigger. All right, so make sure you have all that down. You can go back and reference. And then let's start doing some graphing. And when we graph these, sketching it is just fine. Don't feel like you need graph paper. So we're going to identify those 3 things. We're going to make a sketch. So I've got x squared over 25 plus y squared over 4 equals 1. This is the bigger number. So when I'm thinking about this, that means, oh, a is the bigger number. It's under the x. This is a horizontal one. This is my a squared. This is my b squared. So I need to find my a, my b, and my c. A is 5. B is 2. For C, I do C squared equals, well, those two numbers are already the A squared and the B squared, so I'll just plug them in there. C, that's 21, is equal to the square root of 21. But you know what? We're graphing. This is going to be one place that you can jump straight to that decimal. You don't have to show me any simplifying. So 4.58, and really, who's going to be able to tell the difference? We'll just say 4.6. So the vertices, covertices, and foci. The important part is to get that A in the right spot, the X or the Y. Well, if it's underneath X squared, the A is going to go in the X position, so plus or minus 5, 0. Covertice is the B, so the B is 2. It's along the other axis, so 0 plus or minus 2. The foci should be along the same axis as the vertices, so it's in the X position here, so plus or minus 4.60. So when I go to graph, I graph the center. I'm not having you put that because it's always going to be the origin here. Great to draw it in. If you forget, not a big deal. We're going to go 5, 0, negative 5, 0, 0, 2, 0, negative 2. And then I like to make my ellipse first. You think my circles are bad? You're going to get some bad ellipses here. We'll call that an ellipse. I know a little bit more like a pointed football on this end particularly, but that's good enough. And then our foci should always be within. And so here's 4.6 roughly. Here's 4.6. Both are within there, so we're good shape there. All right, next one. X squared over 9 plus y squared over 16 equals 1. It's equal to 1, so we're in good shape. Here's the bigger number. That's my A, but it also means it's a vertical one. So my A is 4, my B is 3. I've got to do my C squared. 16 minus 9. Well, let's see, 16 minus 9, we're going to get 7, so C equals the square root of 7. So let's see, I've got that here. We're going to call that 2.6. We're going to need the vertices, the covertices, and the foci. So vertices, here's my A, it's underneath the Y, so we have to go 0 plus or minus 4. Then we flip for the covertices, plus or minus 3, 0. And the foci, we're going to have 0 plus or minus 2.6. So 0, 4, negative 4. And then I do have that center in there. And then 3, 0. So this is looking a little bit closer to a circle, but it's not because the A and the B are different numbers. Well, that's a little better, maybe, not great. And then I'll go ahead and I'll put the foci in there. 1, 2.6, 1, 2.6. So both within that ellipse. So we're in good shape. All right, this would be a good one maybe to try on your own, see how you do. So hopefully you tried that and you're back. This is equal to 1. Think about what's under here. There's a 1 under there. This is a bigger number, so it's going to be a horizontal. My A is going to be 3. My B is going to be 1. So C squared is 9 minus 1. So it's the square root of 8. Again, I'm giving you a little break here. You don't have to simplify that. Let me turn my page here. I hopefully have that somewhere. Well, Miss Hogue, you do not have that somewhere. Let's see, it's going to be close to 3. So it's going to be 2 point something. Can't believe I don't have that. Well, let me grab my calculator. I wouldn't be able to tell much on the graph. Sorry about that. But I do want to make sure this is somewhat exact. So we'll do the square root of 8. So we'll call it 2.8. All right, so vertices, covertices, and foci. And this is all the work I should be seeing for you as well. A is underneath the X, so the A is going to go in the X position, plus or minus 3, 0. 0 plus or minus 1. And then C is my foci, plus or minus 2.80. So to my graph I go 3, 0, negative 3, 0, 0, 1, negative 1, so a skinny 1, 2.8. It's going to be really close. That's why sometimes I like to get my ellipse done first. Man, my ellipses are rough today. But you get the general idea. Obviously, yours probably are going to look better than mine, but if they don't, that's all right too. All right, then we get to some of these that are, whoa, wait, we don't see fractions. The other problem, not equal to 1. So you're not really concerned about these numbers. Your goal is to get that 1. To make that 1, I could divide by 400. That means I'd have to divide these by 400. Well, if you put that in your calculator, if you do 16 divided by 400, you're going to get 1 over 25, so x squared over 25. And 25 divided by 400, you're going to get 16. For most of these, for right now, because it's at the origin, you are going to see these numbers flip-flop, but go ahead and divide just to make sure. And so there we go. Oh, so there's my A, bigger number, 5. Smaller number, B, 4. C squared equals 25 minus 16. That means C equals the square root of 9. Well, that's a nice one. It's 3. Whoops. Vertices, co-vertices, foci. You don't have to do it in that order, but I think it goes pretty nicely. Bigger number under the x, so plus or minus 5, 0. 0 plus or minus 4, plus or minus 3, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Foci. They're not as wide. Let's see if I can do any better here. First half's not bad. It's that second half that I struggle with. All right, so there's that ellipse. Let's do one more. Go ahead and try this one on your own if you want. If we did that and came back, we're going to divide each of these by 225. So we're going to get x squared over 9 plus y squared over 25 equals 1. Remember, that's the goal, is to get it equal to 1. Well, this is bigger, so that means my A is 5 and my B is 3. C squared equals 25 minus 9. Well, another nice one, that's 16. So that's going to give me 4. So the vertices, it's under the y, so 0 plus or minus 5. That's going to be the trickiest thing, or what you're going to miss if you're going too fast, is getting that in the right spot. And then the rest fall into place, hopefully. Plus or minus 3, 0. 0 plus or minus 4. So 0, 5. And I know the foci is right under it. There's the foci, there's the vertex. There's one, and there's one. Those are the co-vertices. Okay, let's see if I can do any better here on this. Not great. Maybe my best one yet, though. All right, that's the graphing section. Now we're going to get into writing the equation, rather. Sorry. So to write the equation, we need to know the A and the B, because we need A squared and B squared. They're going to give us two things, a foci and a vertex and a co-vertex, a co-vertex and a foci. So all those different combinations. So remember, vertex, we're always going to have plus or minus. So it doesn't really matter the sign of this, because it's at 0, or the origin, centered at the origin. So we're not worried about the sign, because for either one of those, we're getting that. The vertex is my A. The focus is my C. So if I'm given these two things, I can figure out A squared is 64. So that's going to be part of my equation. C squared is 16, but I need B squared. So I need to do 16 is equal to 64 minus B squared. So then I'm going to do 16 minus 64, negative 48, equals B squared. Negative B squared, rather. So B squared equals 48. Now, you could take the square root, but think about what we want in either one of our formulas. If I go back quickly, we want B squared. B squared. So you don't have to simplify. You don't need to take the square root. Whoops. We want the B squared. So the other thing we have to figure out is where's that a going to go? We know we're going to have x squared plus y squared. We know it's going to equal 1. Does the a go under the x or the y? Well, find where your a is. It's in the x position, so the a squared goes under x. B squared goes under y. There's my equation. Let's try another one, a vertex and a covertex. So the vertex is A, covertex is B. So A squared is 49, B squared is 4. I don't even need to find C squared because I'm not going to use it. I'm going to do x squared over my A because the A is in the x position, so over 49, plus y squared over 4 equals 1. Always plus, always 1. There is an equation that uses negative, but it forms a different type of graph, which we won't be able to get to, unfortunately. All right, so this one, why don't you give it a try on your own? We've got a vertex, 0, 8, be the same thing as 0, negative 8. Focus, 0, negative 3. So that's my A, that's my C. So A squared is equal to 64. C squared is equal to 9. So I'm going to say 9 is equal to 64 minus B squared. B squared, I could go ahead and jump to that. We're going to do 64 minus 9. That's going to give us 55. I got to figure out where that A squared goes. Well, A is in the Y position, so it's going to go underneath the Y squared. So 64 is going to go there. That's going to be the part that's a little tricky, is making sure you get the A in the right position. All right, so this is the only one we haven't tried, covertex and focus. Covertex is B, focus is C. So we know B squared is 36, C squared is 25. So we're going to say 25 equals A squared minus 36. So we're going to add 36 this time. So we're going to get 61. We always want our A squared to be bigger, so that makes sense. Now, we got to think about it here. The covertex is the smaller number. It's underneath, or it's going to go underneath the y. The A squared is the bigger number. It should be in line with the focus. It's underneath the x. So we should get x squared over 61 plus y squared over 36 equals 1. Okay, I'm going to go ahead and give you the assignment. So the assignment is in, again, that packet from the beginning of March, the Chapter 9 packet from the other book. I will attach a PDF of it as well. You're going to do page 637. You're going to do 3 through 9 odd. Make sure you sketch the graph. You don't need graph paper. Make sure you include the vertices, covertices, and foci. Then you're going to go 15, 16, and 20 through 25. When you are done, you are going to use, if I could spell, Google Classroom and turn it in, or you can email me and turn it in, and then turn it in on Classroom to help us stay a little organized. And again, if you have any questions, please just let me know. I'm here to help. I'll get back to you as soon as I can. Talk to you guys soon, I hope.